What is the most dangerous thing in the universe? You might think of a supermassive black hole swallowing solar systems, or a gamma-ray burst sterilizing half a galaxy. But the true ultimate weapon might be something so small you couldn't even see it with a microscope. It doesn't explode, it doesn't burn, it just touches you. And if a single microscopic piece of this substance were to touch the Earth, our entire planet would be completely destroyed in a matter of hours, transformed into a hot, dense lump of dead matter. Welcome to the terrifying, mind-bending physics of strange matter and the apocalyptic threat of the Strangelet. To understand how a subatomic particle could eat a planet, we need to quickly review the rules of reality. Everything around you, your phone, your coffee, the bird outside your window, is made of atoms. Atoms are made of protons and neutrons. And if you zoom in even further, those protons and neutrons are made of fundamental particles called quarks. In our normal universe, there are mainly two types of quarks doing all the heavy lifting: up quarks and down quarks. They are stable, reliable, and frankly, a bit boring. They stick together, follow the rules, and build the universe we know. But nature hides a much darker, much stranger secret. When a truly massive star reaches the end of its lifespan, it doesn't just fade away quietly into the cosmic night. Instead, the delicate balance between gravity pulling inward and nuclear fusion pushing outward violently breaks down. Gravity wins the ultimate arm wrestle. The star collapses and then rebounds in a spectacularly violent supernova explosion, blasting most of its outer layers deep into the surrounding galaxy. But what is left behind in the center is something completely defying human common sense. The core collapses under such unimaginable gravity that it crushes entire atoms together. Protons and neutrons are forced to melt into a literal soup of pure subatomic particles.
Today we are looking at the incredibly dense remnant
This forms
of a
a
massive
neutron star. To comprehend this density, imagine taking the entire mass of Mount Everest and shrinking it down. A single teaspoon of neutron star matter would weigh around 1 billion tons. If you dropped it, it would punch straight through the Earth. Now, if we journey into the absolute center of this dead star, things get even weirder. Down here in the core, the pressure is so unbelievably extreme that the fundamental laws of physics begin to panic and break down. Our reliable friends, the up and down quarks, are suddenly squeezed so tightly that they can no longer maintain their structure. They are literally forced to change their identity to survive this cosmic hydraulic press. Under this apocalyptic pressure, they undergo a quantum transformation into a third, heavier, and much more exotic type of particle. Enter the true antagonist of our story, the strange quark. Unlike normal matter, the strange quark is completely unbothered by the apocalypse around it. In fact, it thrives in it. When you combine up, down, and strange quarks in equal numbers, you get something entirely new. You get something called strange matter. And according to some of the smartest physicists on Earth, strange matter might be the absolute perfect state of existence. Normal matter is inherently unstable and energetic. Strange matter is completely stable, perfectly dense, and virtually indestructible. It is the lowest energy state in the universe. It is matter that has finally reached total enlightenment, but there is a catch. Because strange matter is so perfect, it's incredibly contagious. Think of normal matter as a messy, disorganized room. Strange matter is a perfectly organized, highly efficient filing cabinet. If strange matter comes into contact with normal matter, it doesn't just push it aside. It actively teaches it how to be perfect. The strange quarks force the normal up and down quarks to convert, assimilating them instantly. It's an unstoppable subatomic chain reaction. If you drop a piece of strange matter into a block of iron, the iron doesn't break. It just instantly turns into more strange matter, releasing a massive burst of energy in the process. Fortunately for us, this perfect substance is locked safely away in the crushing core of neutron stars, millions of light years away, right? Well, mostly. Sometimes two neutron stars collide. When this happens, it is one of the most violent events in the cosmos. The collision spits out heavy elements like gold and platinum, but it could also eject tiny, microscopic droplets of the core. These ejected fragments of strange matter are called strangelets. They are smaller than a speck of dust, completely invisible, and they are floating freely through the vacuum of space. Right now, countless strangelets could be drifting through the Milky Way. They don't emit light. They don't have a magnetic field. They are the ultimate stealth assassins. A strangelet could travel for billions of years without hitting anything, just drifting in the cold dark. But eventually, statistics demand that one of these microscopic bullets will intersect with the solar system. It could pass harmlessly through a gas giant like Jupiter or crash into a dead moon. But what if one was on a direct collision course with the third rock from the sun? If a strangelet hit Earth, you wouldn't see a flash in the sky. It wouldn't leave a massive crater. Because it is so incredibly dense, it would slice through the Earth's atmosphere and crust like a bullet going through warm butter. It would plummet straight down to the center of the Earth, pulled by gravity. And once it settled in the Earth's core, surrounded by millions of tons of dense iron and nickel, the ultimate infection would begin. The chain reaction would start at the core and expand outward exponentially. Deep underground, the Earth's iron core would boil and convert into strange matter, releasing apocalyptic amounts of heat. Massive earthquakes would shatter the tectonic plates. The oceans would boil away into massive clouds of steam almost instantly. Within hours, maybe even minutes, the conversion wave would reach the surface. Everything, the mountains, the cities, the water, and the very atmosphere, and you would be instantly assimilated. The Earth would lose all of its structural integrity. It would shrink violently under the intense gravitational density, from a beautiful blue planet into a perfectly smooth, red-hot sphere of strange matter, about the size of a small asteroid. So, the Earth is gone, reduced to a tiny 100-meter nugget of perfect strange matter. But gravitationally speaking, absolutely nothing has changed. The nugget has the exact same mass as the old Earth. The Moon would continue orbiting this tiny, invisible dark dot exactly as it did before. Except now, the night sky on the Moon would be completely devoid of the beautiful blue marble. But this is just a localized planetary tragedy. What if the Strangelet missed us entirely? What if it flew right past Earth and plunged directly into the heart of our Sun? The Sun is a massive ball of fusing plasma, over 1 million times larger than Earth. But to a Strangelet, size doesn't matter. The Sun is just an all-you-can-eat subatomic buffet. Plunging into the core, the Strangelet would initiate the exact same unstoppable chain reaction. The Sun's normal roaring plasma would be aggressively converted into strange matter. It wouldn't blow up. Instead, it would violently shrink, collapsing into a strange star. A strange star would be incredibly small, incredibly dense, and significantly dimmer than our current Sun. Without the intense, roaring heat of normal nuclear fusion, the solar system's thermostat would instantly crash. The remaining planets, including Earth, would be plunged into a permanent, eternal ice age. The solar system would become a dark, frozen graveyard, orbiting a tiny, perfect, purple corpse of a star. But before you panic and try to build a Strangelet-proof bunker, the odds of a wandering space Strangelet hitting our tiny planet are astronomically low. However, there is another, much closer source of anxiety. What if the threat isn't falling from space? What if we accidentally create a Strangelet ourselves? Enter the Large Hadron Collider in Switzerland. Here, physicists smash atomic nuclei together at 99.99% the speed of light to break them apart and study the fundamental building blocks of the universe. But before it was turned on, there was a genuine wave of public panic. News headlines warned of the apocalypse. The fear was simple. If we smash atoms hard enough, could we accidentally compress them into a Strangelet? Could a single lab accident in Geneva turn the entire planet into a purple bowling ball? Fortunately,
according to our
the world's top
calculations right
physicists
here,
ran the math,
everything checks
and we are
out.
completely
We are
safe. It
This
turns
process
out,
requires
creating
intense
strange
pressure,
matter isn't just
as
about
heat is
smashing
simply
things
the
together.
wrong environment.
You need a very specific environment. A neutron star provides unimaginable crushing pressure, allowing the quarks to stabilize. But particle accelerators, like the LHC, do something else. They create unimaginable heat, trillions of degrees. At these blistering temperatures, strange matter simply cannot stabilize. It would be like trying to form an ice cube inside a roaring volcano.
It's
So,
100%
human experiments are
safe.
completely safe. But the universe has its own, much more powerful particle accelerators. Every single second, the Earth is bombarded by cosmic rays. particles fired from distant black holes and supernovas. These natural projectiles hit our atmosphere with millions of times more energy than the Large Hadron Collider could ever produce. And yet, after 4.5 billion years of this relentless cosmic target practice, the Earth is still here, completely unassimilated. If high-speed collisions easily created planet-eating strangelets, we wouldn't be here to worry about it.
But what about the ones created in
neutron star collisions? The stealth assassins drifting through the void. Many physicists believe that strangelets might not be stable at small sizes. Stripped from the crushing pressure of their home star, a microscopic strangelet might actually be incredibly fragile. As it drifts through the vacuum of space, it might slowly leak energy, evaporating harmlessly back into normal, boring quarks. There's also a wilder theory. Some scientists suggest that strangelets might actually be the elusive dark matter, the invisible mass that holds galaxies together. If that's true, strangelets wouldn't interact with normal matter like a virus at all. Instead, they would pass straight through the Earth like subatomic ghosts, completely ignoring our atoms. So, the apocalyptic scenario we just imagined, it remains purely theoretical. A mathematical nightmare locked safely inside the equations of quantum mechanics. And perhaps that is the greatest comfort we have. We live on a tiny, fragile blue marble, protected primarily by the sheer, unimaginable vastness of space. The universe is filled with unimaginable terrors, from planet-eating subatomic particles to exploding stars. But we are made of the very same imperfect, fragile matter that we are so afraid of. And our ability to understand, to calculate, and to explore these terrifying concepts is what makes human existence so incredibly beautiful. If you want to keep exploring the terrifying and wonderful secrets of the universe with us, make sure you don't get assimilated. Hit that subscribe button. Leave a like if you enjoyed this journey into the bizarre world of quantum mechanics. And let us know down in the comments, what cosmic disaster should we cover next? Ring the notification bell so you never miss a new video. Check out our other videos on screen right now for more existential dread. A huge thank you to our supporters who make these videos possible. We couldn't do it without you. Thanks so much for watching, and as always, stay curious.